correct? So you will have alpha plus beta minus alpha minus beta. What is that? A0. So you take any two different elements of A alpha type, you will always get identity. Now if you take Q of A alpha and B alpha, if you take Q of A alpha and B alpha, what will you get? Generally you can have B beta. So A alpha, B beta, A inverse alpha, B inverse beta. By the way, what is B inverse of beta? B inverse of beta is equal to A of beta P inverse, which is equal to P inverse A of beta inverse. That is equal to P inverse A of minus beta. But what is P inverse? P square is 1. So P inverse is P itself. So this is equal to P into A of minus beta, or this is equal to A of beta into P. This is equal to B of beta itself. So all these B's are self inverses. All these B elements are inverses of themselves. So B inverse beta is same as B beta. Okay. Now you can ask what is this. So A alpha into A alpha, A beta of P, A beta P. This is A minus alpha, and this is B beta, which I will write it as A beta into P. So this is equal to A alpha, A beta. I will push this P here. I will make this as A alpha. I will push it there. This will be A beta into P square. P square is 1. So this will be minus beta. Correct? So this is going to be alpha plus A2 alpha, alpha plus alpha, right? So by choosing A alpha B beta, we will get A alpha. Correct? Now if I choose B alpha B beta, what will I get? B alpha B beta identity. Suppose if I choose, okay, I will leave it for you to verify. You will get again one of this A alpha only, so that you can say that the commutator group of this one is actually SO2. Only all elements of SO2 we will have. And what is the factor? What is the factor group? O2 factor SO2 is equal to identity matrix and then P matrix, a 2-element group. The factor group is just a 2-element group. Now we know that So let us classes. So A of 0 is a class by itself. A of 0 is a single class, but we have already seen that A of theta, P A of theta is A of minus theta P, which means A of minus theta can be written as P A of theta into P inverse. That means these two belong to same class. So we have A of theta and A of minus theta is a class for each theta. So we have a class of two elements for each theta. Then we have B of theta or all theta is another class, because you can see every B of theta will be shown to be you can show it to be that it is conjugate to every other B of theta. How do you show? B of theta, you can write this as any other B of phi. So which element you should write here? You should write some element here, A inverse. What element will you write? What is, please remember what are the rules that we have. A of theta, A of phi is equal to A of theta plus phi. A of theta, B of phi is equal to B of theta plus phi. And B of theta, B of phi is equal to A of theta minus phi. And B of phi, A of theta is equal to B of, can call this as theta and phi, doesn't matter, theta minus phi.
Same relation you cannot say about theta and B minus theta.
They will be conjugate to each other, but there is something more. In fact, not all B of theta are in one class. All B of theta are in one class. B theta and B minus theta are already conjugate to each other. So I am saying you take any B theta and B phi, you can relate it through this conjugate relation. So I am asking, what is this A that conjugates any B phi to any B theta? So let us say that, okay, let us conjugate it and see. Suppose if I use P here, then what happens? Huh? Yeah, P and P inverse. P inverse is same as P. P? B minus B of minus phi. Yeah, I think so. So let us put, because if I put a theta here, then I put a minus theta here. Correct? So what is B phi A minus theta? B phi plus theta. So what is A theta into B phi plus theta is B phi plus 2 theta. Okay, so I want this theta to, I want this I must take phi minus theta. No, I can simply choose phi plus theta should be equal to 0. So I should take, okay, so maybe if I do this phi plus alpha, right, alpha, so this will be b of phi plus 2 alpha. So that means I want this phi plus 2 alpha to be equal to theta. So my alpha I should choose as theta minus phi by 2. So by choosing an angle alpha as theta minus phi by 2, I can relate any b theta to any. So essentially b of theta is equal to a of theta minus phi by 2 into b of phi into a of theta minus phi by 2 minus. So through this operation I can conjugate any b phi to any b theta. Phi and theta are arbitrary. So all of these b theta are in one class. Okay. So the class structure is like this. Identity is one class. There are infinitely many 2 element classes. There is one class with infinitely many elements. Okay. One element class, infinitely uncountably infinitely many 2 element classes, one class with uncountably many elements. Now we can talk about a group which is a little more familiar to us in terms of we use this, at least this language in classical mechanics. This is called SO3 group. This is special orthogonal group in 3 dimensions, a rotation group in 3 dimensions. So this is 3 by 3 real matrices, A such that A transpose A is equal to identity and determinant of A is equal to plus 1. Now how do we represent this matrix? A general 3 by 3 matrix. How many parameters are required? We require 3 parameters. In the previous case, only one parameter, SO2 required only one parameter. O2 also required only one parameter, whereas SO3 requires 3 parameters. Now how to choose these parameters? There are different ways in which you can choose. Any arbitrary rotation can be described by fixing an axis of rotation and an angle of rotation. So such a description is called axis angle description. Okay, so you can fix an n cap, a unit vector n, and a kind of an angle alpha. So this is called axis angle variable. Axis angle variable. Yeah, see, this is one parameter. Other parameter is your Euler and angle parameters, psi, theta, phi. These are 3 angles. So 3 parameters can be chosen differently. An arbitrary rotation can be, you can come to any rotation by rotating through Euler and angles or by choosing an axis and do one rotation. Equivalent descriptions. Fixing an axis require 3 direction cosines, which means 2 parameters, n1, n2, n3, such that n1 square